Hi and welcome to Chemipedia chemistry classes for 11th standard. So in this video I'm going to discuss about redox reaction and types of redox reactions. First let us see what is redox reaction. So chemical reaction in which both oxidation and reduction occur simultaneously. So redox reaction is the one where oxidation reduction both reaction occurs at same time. Okay. So this is the definition of redox reaction. Basically oxidation is nothing but increase in oxidation number, reduction is nothing but decrease in oxidation number. So that in case of redox reaction, so both will take place. There will be an increase of oxidation number of certain atom, as well as there will be decrease in oxidation number also. Okay, so that is the nature of redox reaction. So actually we have 5 different types of redox reactions. Okay, the first one, combination reaction. Basically combination reactions are the reactions in which two substances combine to form a single compound. Reaction in which two substances combine to form a single compound is generally called as combination reaction. Okay, whereas combination type of chemical reaction has redox nature. So for example, look at the example given here. Okay, carbon reacts with oxygen giving carbon dioxide. Here two substances combining and giving a single compound, isn't it? So it's a combination type of reaction, and it follows even redox condition also, because left side oxidation number of carbon is about 0 because it is in element form. Even oxygen oxidation number also 0 because carbon oxygen both are in free state, uncombined state, so their oxidation number is equal to 0, isn't it? Then it gives carbon dioxide, whereas in carbon dioxide oxidation number of oxygen is -2. It is the common oxidation state of oxygen. Then carbon +4, because there are two oxygen atoms, 2 into -2 -4, therefore carbon has +4 oxidation state. Right, now look at the oxidation number change. The oxidation number of carbon changes from 0 to +4. There is an increase in oxidation number, isn't it? It's nothing but oxidation. So here carbon is getting oxidized into carbon dioxide, isn't it? So now look at oxidation number of oxygen. It changes from 0 to -2. So there is a decrease in oxidation number, isn't it? So oxygen is getting reduced. But it's a single reaction in which both oxidation and reduction occurs. So it is a redox reaction which comes under combination type of chemical reaction. Okay, right. That's the first type of redox reaction. The second one, decomposition reaction. So decomposition reaction is the one in which a single compound breaks down. A single compound breaks down or decomposes into two or more components. Okay, so decomposition, one compound breaks into two or many, isn't it? Okay. Now let us see one example for that. Twice KClO3 on thermal decomposition. Heating gives twice KCl plus thrice O2. KClO3 is nothing but potassium chlorate, RATE, chlorate. This on heating undergoes thermal decomposition giving potassium chloride, KCl, and oxygen gas, isn't it? Right, now let us see the oxidation number changes. Okay, whereas in potassium chlorate the oxidation number of chlorine is +5. I think you know how to calculate oxidation number, isn't it? So in the previous videos we have discussed about the oxidation number assigning for an atom in compound, ion, etc. Okay, right, now here it is +5, whereas right side it is -1. For chlorine oxidation number is -1, isn't it? But now the oxidation number of chlorine decreases, isn't it? Decrease in oxidation number, so it is nothing but reduction. But chlorine is getting reduced. Now oxidation number of oxygen, so in potassium chlorate it has -2 oxidation state. Right side 3O2, uncombined state, elemental form than a molecular form otherwise, isn't it? But here oxidation number of oxygen is 0. But oxygen oxidation number changes from -2 to 0, which means there is an increase in oxidation number. So which is nothing but oxidation, isn't it? But now here chlorine is getting reduced, oxygen is getting oxidized. So it's a kind of redox reaction which comes under decomposition type. Okay, this is the second type. Then the third type, displacement reaction. Third type is displacement reactions. Even some displacement reaction also follows redox type. Okay, in displacement there are two different category. One is metal displacement reaction, another one is non-metal displacement reaction. So what is the difference between metal displacement And non-metal displacement. In metal displacement reaction, a metal displaces another metal from its salt solution. Whereas the second category, non-metal displacement reaction, a metal will displace a non-metal. A metal, here metal to metal, there a metal displacing a non-metal. Okay, first let us see metal displacement reaction. Okay, right. So this is the definition actually. A metal is displacing another metal from its salt solution is generally what we call metal displacement reaction. Okay, so look at the example with copper sulfate solution, aqueous copper sulfate solution, when we add zinc solid. So it gives copper solid plus zinc sulfate solution, aqueous, isn't it? Right. Now with blue color copper sulfate solution, we are adding zinc powder. Now what is happening is that zinc is displacing copper. So copper metal is liberated along with formation of zinc sulfate solution, isn't it? Right. Now here in copper sulfate, the oxidation state of copper is +2, whereas right side it is in element state, so 0 oxidation state. So the oxidation state of copper changes from +2 to 0, decrease, isn't it? So now, which means that copper is getting reduced, isn't it? Similarly, oxidation state of zinc on left hand side is 0 because it is in elemental state. Right side it becomes zinc sulfate, which is in +2 state. But now oxidation number of zinc changes from 0 to +2. There is an increase in oxidation number, which is nothing but oxidation. Up here zinc is getting oxidized, copper is getting reduced. Both oxidation reduction occurs. So it is a example for redox type of reaction in which a more electropositive metal is displacing a less electropositive metal, or a metal is displacing another metal from its salt solution. So that's why it's a metal displacement reaction. Okay, right. The next one, non-metal displacement reaction, which means a metal is displacing a non-metal from its compound, isn't it? So look at the reaction. Zn plus 2HCl. So zinc metal reacts with hydrochloric acid, dilute hydrochloric acid, giving zinc chloride salt, Zn Cl2 salt with liberation of hydrogen gas. Okay, so now let us check the oxidation numbers. Here actually this is non-metal displacement because the Zn displaces hydrogen from hydrochloric acid. That is the reason why you are getting zinc chloride. Okay, in the place of H, zinc is displaced, isn't it? Right. Okay, now the oxidation state of zinc on left hand side is 0 because it is in elemental state. So right hand side Cl oxidation state -1. So 2 times -2, therefore zinc with oxidation number +2. Therefore oxidation number of zinc changes from 0 to +2. There is an increase in oxidation number, isn't it? So that it is an oxidation reaction. So in this particular reaction, zinc is getting oxidized, isn't it? Similarly, in HCl, the oxidation number of hydrogen is +1 because chlorine -1, hydrogen +1. Then right side you are getting H2, some molecular form, uncombined state. So oxidation number is 0. Now the oxidation number of hydrogen changes from +1 to 0. There is a decrease in oxidation number. ON oxidation number decreases. So it is reduction. So here hydrogen is getting reduced. Zinc is getting oxidized. Hydrogen is getting reduced, isn't it? So it is a redox type reaction. Okay. And it is a non-metal displacement because a metal zinc displaces a non-metal hydrogen from hydrochloric acid, giving zinc chloride with liberation of hydrogen gas. Okay. So these are the two types of displacement reactions. Okay, right. The fourth category is nothing but disproportionation reaction. The fourth type of redox reaction is what? Disproportionation reaction, which is also called as auto redox reaction. The other name of disproportionation is auto redox reaction, self redox reaction. Okay, right. So what is disproportionation reaction? This is a chemical reaction in which a same compound undergoes both oxidation and reduction. Okay, so here in disproportionation, one compound is getting oxidized as well as the same compound is getting reduced also. Okay, so that's what we call auto redox. Okay. So look at the example given here. Twice H2O2. H2O2 hydrogen peroxide on thermal decomposition, giving 2 moles of water and oxygen, 1 mole of oxygen gas, isn't it? Right. Now in hydrogen peroxide, oxidation state of oxygen is -1. You know that the common oxidation state of oxygen is -2. Except peroxides, or only in peroxides oxygen gas -1 oxidation state, isn't it? Right. Now right side, in water oxidation state of oxygen is -2, whereas in O2 it is an uncombined state, so its oxidation number is 0. But now you can see the oxidation number of oxygen changes from -1 to 0, -1 to 0. oxidation number increase. So it is oxidation, as well as it changes from -1 to -2 also. So oxidation number decreases. It's nothing but reduction. Above here, you can see that the same element oxygen is getting oxidized as well as reduced, or otherwise the same compound hydrogen peroxide is getting oxidized as well as reduced, isn't it? For example, if you want to get oxygen from hydrogen peroxide, what you are supposed to do? You have to remove hydrogen. Removal of hydrogen is oxidation. Okay, but conversion of hydrogen peroxide into oxygen is nothing but oxidation. If you want to get H2O from H2O2, you are supposed to remove one oxygen, isn't it? Removal of oxygen is nothing but reduction. So conversion of peroxide into oxygen is oxidation. Conversion of hydrogen peroxide into water is nothing but reduction. But here the same compound hydrogen peroxide is oxidized as well as it is reduced, isn't it? That's what disproportionation reaction. Same compound undergoes both oxidation and reduction reaction. Okay, I have written here H2O2 is oxidized to O2 as well as H2O2 is reduced to H2O. Okay, same compound is oxidized as well as reduced. Okay, self or auto redox reaction. Okay, right. The last one is competitive electron transfer. The last type of redox reaction is nothing but competitive electron transfer. Now, so look at the reaction given. So it's a kind of metal displacement reaction, isn't it? With a blue color copper sulfate solution, with blue color aqueous copper sulfate solution, when we add zinc powder, zinc solid, the zinc will displace copper so that you get zinc sulfate, whereas copper solid or copper metal is getting liberated, isn't it? Right. So this reaction is possible, a feasible reaction, because zinc is more electropositive than copper. So that a more electropositive zinc readily displaces a less electropositive copper. Correct. Now, look at the reverse. Suppose with zinc sulfate, when you add copper, a colorless zinc sulfate, if we add copper metal, if it follows reaction similar to this, copper is supposed to displace zinc, isn't it? So that you have to get copper sulfate solution along with liberation of zinc metal, isn't it? But this reaction is not at all possible. This reaction is practically not possible. The reason is copper is less electropositive, zinc more electropositive. A less electropositive metal cannot displace a more electropositive metal from its salt solution. Okay, right. These two reactions can be observed with a color change, because the first one, the aqueous solution of copper sulfate is blue in color, isn't it? When we add zinc metal with that, the zinc displaces copper, isn't it? As a result of that, you are getting zinc sulfate. So now there is a color change from blue to colorless. That is an indication that this reaction has taken place, isn't it? Suppose if this reaction occurs, zinc sulfate colorless, copper sulfate blue, isn't it? There should be a color change from colorless to blue, but that color change does not occur, which means this reaction is non-feasible, not taking place, because of a less reactive metal or less electropositive metal cannot displace more electropositive zinc. Okay, that's what I have written. Less electropositive copper cannot replace more electropositive zinc. So that colorless to blue change is not observed. It does not occur. Okay, right. Now, so look at another reaction. With a colorless silver nitrate aqueous solution, if you add copper solid, copper will displace silver, because copper is more electropositive than silver, so it readily replaces less electropositive silver. So as a result of that, you are getting copper nitrate solution with formation of silver solid, isn't it? Right. Now, silver nitrate is colorless, copper nitrate is blue. Now here there is a color change from colorless to blue. Okay, a colorless silver nitrate solution slowly changes into blue color due to formation of a blue color copper nitrate solution. Okay, right. Now this reaction takes place. This reaction can occur, isn't it? Right. Now here in the previous one, copper cannot displace zinc, isn't it? This reaction not taking place. But when we add copper with silver nitrate solution, copper can readily displace silver, because copper is more electropositive than silver. Okay, but less electropositive than zinc metal. Correct. So now this is the order of electropositive nature of these metals. Zinc is more electropositive than copper, which in turn more electropositive than silver, isn't it? Which means zinc can displace copper, copper cannot displace zinc. Copper can displace silver, but silver cannot displace copper. Okay, right. So this is the fifth type of reaction, what we call it as competitive electron transfer. Okay, right. Thank you.